Hello guys, hope you're doing well. I'm Sulef and today we'll talk about linear and quadratic functions. The first thing that we'll talk about it is the linear equation. The linear equation has got a standard form, ax plus by equal to c, and in this standard form we've got three constants which are a, b, and c. And at the same time both a, b cannot be equal to 0. Just why mathematically thinking, imagine that a is 0, so we'll have our 0 multiplied by x, which is 0, so we'll raise our x. And the same thing with b, imagine that b is 0, so we will get b multiplied by 0 multiplied by y, and we will get 0, so we will delete our y also. So that's why a and b cannot be equal to 0. And at the same time, in our standard form, we've got two variables, which are x and y. We call them variables. And because we talked about the general form of a linear equation, now we can talk about the graph of this linear equation. So the graph of a linear equation is always a line in a Cartesian coordinate system. So this is what we call it, a line. So always the linear equation, the graph is a line in a Cartesian coordinate system. And let's see now why do we mean by a Cartesian and a line. And now let's talk about this line. This is the graph that we're talking about it. We said that the linear equation is a line. So this is the line. And now let's have a brief information about the slope. What do we mean by the slope m? If we want to calculate the slope using the graph, what should we do? We have to take 2 points. Point A from the graph and point B from the graph also. So point A, we have x, A, and y, A. This is, let's say that this is A and this is the point B. This is A and this is point B. This is the XA and this is the XB. And this is the YA, and this is what we call it, the YB. And the second point is B, XB, and YB. If we want to calculate our slope, what should we do? We have to take the YB minus the Y1 divided by XB minus the X1. This is our slope of the line of our graph. Now let's talk about our geometric interpretation of a slope. Imagine that our slope is positive number, for example 2, 3, and etc., a positive number. Our line will be raising from the left to the right. This is what we call it, raise. Our line will be raising from the left to the right. This is when we have the slope positive. Now imagine that our slope is negative, -2 or -3, for example, or any negative number. So here our line will be not raising but falling from the left to the right also, but not raising like the first graph, but falling. This is when we have a negative slope. Now imagine that we have a horizontal slope, which means 0, we have a slope of 0, so the line will be horizontal. This is what we call it, horizontal slope. And at the same time, if we have a slope which is not defined, our line will be vertical. Now we'll talk about equations of a line. We said that the standard form of a line is ax plus by equal to c. This is what we call it, the standard form, the general form of a linear equation. And of course, a and b cannot be 0. Just imagine that a is 0. For example, 0 multiplied x, we will get 0. So we will not have our x. And the same case with y. Imagine that y is 0, y multiplied by 0, we will get 0. So we will not have our variable x or y. This is why a or b both cannot be 0. And the second thing that we'll talk about it is the slope-intercept form. This is the standard form, and now if we want to have the slope-intercept form, how can we do it? We have the ax plus by equal to c, and if we want to move on from this form to the slope form, let's take the ax from the other side. So we will have minus ax plus c, and if we want to continue the case, this is what we're going to have: y equal to minus a divided by b plus c. So, and this is the final result that we will get to it. Y equal to minus a divided by b plus c divided by b. And this is what we call it, the slope-intercept form. And if we want to calculate the slope in other methods, not in geometric method, this is the equation that we have to use: minus a divided by b to find our slope in the graph. Now let's talk to the point slope form. If we want to find the slope, not with the equation, but with the graph, and we have 2 points, for example, the point A, which is x1, y1, and B, which is x2, y2, and we want to find our slope, we can do like this. M is y2 minus y1 divided by x2 minus x1. So we said that we have 2 points in the graph, point A and point B, and we want to calculate our slope. How could we do? Let's take the first y from B and minus the second y from A, second point, and the first x from B minus the second x from A. And this is how we can get our slope without an equation. And now, if we want to find our horizontal line, what should we do? We said before that when we have a horizontal line, it means that the slope is 0. So if we want to find this horizontal line, let's take like this. We have to make x equal to 0. Okay, this is the equation that we have. For example, y equal to mx plus b. To find the horizontal line, we can take the x equal to 0. So m multiplied 0, we will have 0. So that's what we can conclude that y equal to b. This is when we have the horizontal form of an equation. And now let's talk when we have the vertical form of an equation. What should we do? When we have the vertical form of an equation, the y will be equal to 0. And our slope, as we said before, will be undefined. And now let's go to the next slide. In this chapter, let's talk about the interval notation. Imagine that we have a domain AB closed from the both sides, and at the same time we have the inequality notation, which is x bigger than a, and at the same time x minor than b. So if we want to have the line graph, because it's closed from the both sides, and here we said that it's bigger than and equal, and here we said that it's minor than and equal. So in the line graph, we'll have both closed part from A and B. Just because we have bigger than and equal and minor than and equal. Let's talk about the next example. Here, because from this side, we have x is minor than b, but it's not equal. We don't have this slash of equal, so that's why from in the line graph from the b, we will not close it, but we will have a parenthesis. But just because from a we have x is bigger than a and equal, this is the slash of equal, so in the line graph we will close it like this. We will not make a parenthesis. And in the third example, what do we have? X is bigger than a, but it's not equal. You can see here we do not have this slash of equality. So when we have to make the line graph from the A side, we will not close it, but we will just make a parenthesis. What do we mean by a parenthesis? We mean that the number A is not entered in this domain. Let's give an example with number. You will understand better. Let's say that x is bigger than 2 and smaller than, let's say, 5. So here, if we do not have the equality here, so if we want to draw the line graph, we will do like this. 2 and 5, and we have here 3 and 4. If we do not have here the equality, and if we make a parenthesis here, it means that 2 and 5, they are not entered in this domain. But for example, if we have the equality here, so we make the parenthesis, but we will close it from both sides. So here, it means that the number 2 and the number 5 are included in this domain. So then, let's talk about the next case. Imagine that we have minus infinity and a. We're talking about this. So here, of course, minus infinity, it means that we don't have a defined number. So we'll just close it from the A side and you'll let it open from the minus infinity. We'll not make a parenthesis just because it's an undefined function. And it's the same time, the same thing for here we have b and infinity. We didn't close it from the infinity part because it's defined. We don't even make a parenthesis. And at the same time, because b it's not equal, so we will just make a parenthesis. We will not close it. And we means here that b is not included to the domain. The number b is not included to the domain. I hope everything is clear until now. And now let's go to the next slide. Here we'll talk about the linear function. This is the linear function that we have. Actually, it's how we can go from the standard form to the linear function before, to this, with that we call it also the slope form. And we call it fx. At the same time, we can call it y. It's mx plus b, and m is defined by the slope. Now let's talk about the quadratic functions. What do we mean by a quadratic function? It's just like the linear function. We have a, b, and c as real numbers. We're not equal to zeros. At the same time, a or b or c cannot be a or b cannot be equal to zero, but are numbers. And of course, we have x power 2. We should have power 2. This is why we call it a quadratic function when we have a power 2. And if we want to talk about the graph of a quadratic function, it will be a parabola. What do we mean by a parabola? This is a parabola function. In general, this is a graph of quadratic function. And now we have got the general form of a quadratic function, and at the same time we've got the vertex form of a quadratic function. And as we did before, how can we go from this general form to the vertex form? What should we do first? So now we said that what we call it the general form of the quadratic function, and now what should we do to go to the vertex form? First, let's take the -3 as a common number. So what do we have next? X power 2 minus 2x and -1. What can we do next? We can enter the 3 as a number. We can write here plus 1, and inside the square we can write plus 3. As we did before, this is the result that we get it. -1 plus 3. Here, just because -3, if we multiply it with 1, we will get -3 with this 3 inside, so as we didn't do anything. So here, if we can calculate this one with a calculator, we will have 1 as a root, so we can write it like this, and -1 plus 3 will get 2. And this is what we call it the vertex form of a quadratic function, with 1 and 2 as the vertex point. And after that, we'll see what we can do with our vertex point. So this is how we can go from the general form to the vertex form of a quadratic function. And now we have another question. Let's say that we want to find the x and y intercepts of a function. Let's first start with x intercepts to a function. If we want to get x-intercept to a function, we have to take the function equal to 0. Take our function and make it equal to 0. Then, of course, we can calculate it with a rule that we have to learn it by heart. The rule is x equal to minus b. First, let's talk like this to understand what is the a, b, and c. So this is what we call it ax squared plus bx plus c. So here, if we want to calculate the roots of this function, we have to take minus b, here minus b, which is 6 minus 6, plus b power 2, which is 6 power 2, minus 4, a multiplied by c, a which is minus 3, multiplied by c, which is minus 1, divided by 2a, which is 2 multiplied by minus 3. And when we calculate it, we will get this number. So this is how we can calculate the x-intercept to a function. Let's say it again to understand better. If we want to find x-intercept to function, let's take our function and make it equal to 0. The function, this is our function, and make it equal to 0. We will get these results. Then, when we have a function like this and we want to find the roots, we have to learn a rule by heart, which is this rule. And then, while applying this rule, we will get a result. And this is what we said x-intercepts to a function. Now, let's talk to when y-intercepts to a function. If we want to find when y-intercepts to a function, it's easy. Just at the place of x, we will replace it by 0. At the place of x here and here, we will replace it by 0. And then we can find our number, which is minus 1, f0 minus 1, and this is a function when y intercepts to a function, and this is the point that we will get 0 minus 1. So if we want to find y-intercepts to a function, let's take the x of the function and replace it by 0. Now let's talk about some rules of the graph to understand how it can be. So here, this is what we call it the vertex form as we did before. And now, if a not equal to 0, a is a number. So our graph, will be a parabola. We said this is what we call it, a parabola. And now, if a is bigger than 0, it means that a is a positive number. Our parabola will be opens upward. This is what we call it, opens upward. And now, if our a is minor than 0, it means it's a negative number. So here, our graph will be downward. It means will be opened like this, downward, not upward, but downward. And here, this is what we call it, the vertex form of a parabola. In general, this is our vertex form, our vertex points, that we calculated before. If you remember, we did the vertex points. How can we find it? Through the vertex form. And this is our vertex point here. And as we said, if our A is positive, we will have the parabola open upwards, and if it's negative, we'll have the parabola open downward. And now we have how we can solve the quadratic inequality. We have a quadratic inequality here, minus x power 2 plus 5x plus 3 bigger than 0. How can we solve this inequality? Sure, with using the rule that we did it before, if you remember. We said that we have to use this rule, minus b minus for c divided by 2a. We can find the roots here. We can find the roots. Our roots are minus 0.5 and 5.5. So this is what we mean that x is between minus 0.54 and 5.5. And here how we can solve our inequality. This is our point, minus 0.5, and this is our second point, which is 5.5. Here we solved our inequality with using the roots. So now we'll try to apply our quadratic functions in a mathematical way. Here we have a problem. They said that a Macon, Georgia peach orchard farmer now has 20 trees. It has 20 trees per acre. Each tree produces on the average 30 peaches. For each additional one tree that the farmer plants, the number of peaches per tree is reduced by 10. Reduced, what we mean by minus 10. The question is, how many more trees should the farmer plant to achieve the maximum yield of peaches? What is the maximum yield? So let's start to calculate the yields. How can we find our yields? The yields, we have to take the number of peaches per tree. This is our number of peaches per tree, 300. And we will multiply it by 20. This is the number of trees. So if we want to find the yield, we will take 300, which is the number of peaches per tree, and multiply it by 20, which is the trees per acre. And here we will find 6,000. This is the yield. Now, what can we do to find what is the maximum yield? So now we'll try to find the general rule and the general equation of this problem. We said that the number of peaches per tree is 300. So we have 300 peaches per tree. And we said at the same time that if we will plant one more tree, we will have 10 minus 10 production of peaches. So this is the first rule. We said that we have 300 peaches per tree, and at the same time, if we will have minus one tree, one tree, just one tree, we will get minus 10 peaches per tree. So this is the first rule, and multiply it by numbers of tree 20, and we said that we will add one tree, so here we will add 1. So this is the general form of our equation. We said this 300 minus 10 per tree. We said for each tree we will have minus 10 peaches. And multiply it by numbers of tree, which is 20, plus 1 because we add one more tree. This is when we plant one more tree. Now imagine that we plant 2 more trees. If we plant 2 more trees, of course, we'll have 300 minus not 1 tree, but minus 2 trees. Multiplied by 10, the same thing. And here we will have 20, not plus 1, because we add 2 trees, so we will have 20 plus 2. So this is the form if we plant one more tree, and this is the form if we plant 2 more trees. And now what we have to do now, did you see this 1 tree, 2 trees, or 4 or stuff like this? We will replace it by x. X will represent the number of trees that we will add it. So if we add 1 tree, here we will replace it by 1 and here by 1. If we add 2, here we will write 2. If we add 4 trees, for example, here we will write 4. So here x, it will represent the number of trees that we will add it. And now, while multiplying this function, we will get this general quadratic function. And now, from this general quadratic function, we want to find our vertex equation. How can we find it? What did we say to find our vertex form? First, we have to take a common number. Here, let's take minus 10 as a common number. We have minus 10 multiplied by x power 2 minus 10x, and we will close our parentheses, plus 6,000. And here, what should we do next? We said that we will add a number here. We will add minus 10x power 2 minus 10x, and here we will add plus 25 plus 6,000, and at the same time plus 250. Why did we add 250 here? Just because if we multiplied 25 by 10, we will have 250. So then we said that it means that we didn't do anything. And this is the form that we'll get it. So minus 10 x power 2 minus 10x plus 25 plus 6,000 and plus 250. We added here to eliminate this number. Okay? And now what should we do? By using the rule that we did it before to find our roots, we can find the root here. And our root will be minus 5. So now we have to write like this. X, while calculating the roots of this function, we showed before how can we calculate the root. We said x equal to minus b minus ac divided by 2a. This is how we can find our root. So now the root that we find it, we'll write it here. Square plus, and if we can sum up these parts, we will find a number which is 6,250. So now this is our vertex form that we find it at the end. And while finding our vertex form, we can answer our question. What did we say? The vertex point that we will get it, we said that our vertex point in general is this number plus this number. So it's 5 and 6,250. And now how can we answer to our question? We will say the farmer should plant 5 additional trees, because we said that x is always the number of trees that we are adding. The farmer should plant 5 additional trees to obtain 6,250 peaches. And this is what we call it the maximum yield. The maximum yield is for 5 more trees, he will get 6,250 peaches. And now let's go to the next example, break-even analysis. So here, the financial department of a company that produces digital cameras has the revenue and cost functions for X million cameras are as follows. So we have the revenues, and at the same time we have the cost functions as follows. This is the revenue function and this is the cost function. And we said that both, they have got a domain. X is between 1 and 15. So if we want to find the break-even analysis, what should we do? We have to take the revenue equal to the costs. So what we'll have then, in algebraically forms, we'll get the revenues equal to costs, and we will have to the nearest thousandth camera. So while having this form, we'll get to a quadratic general form function. And as we did before, we have to calculate the root x with the rule that we said that we have to learn it by heart. And this is the result that we'll get it. And then we can say that the company breaks even at 2.490 and at the same time to 12.330. This is the root that we find them. So let's repeat again. To find the break-even root, what should we do? We have to take the Rx equal to Cx. This is the equation of Rx and this is the equation of Cx. And then we will find, by multiplying these two functions, we will find this general quadratic form, and while calculating the root, we will find our break-even point. And then we can also graph the cost and revenue functions, and we will have this graphing utilities, and we can obtain the 2 points of the graphing utilities also that are at the same time the break-even point. So it was all about the quadratic and linear functions. Hope you learned something with me today. So have a nice day and goodbye.